Very good evening to all and welcome back to the day 2 session. So last class we are discussing about the introduction to your STAAD Pro and overall interface about STAAD Pro, and few questions I have interacted with you, some takeaway questions. So to continue with that questions, so I hope you have tried that questions, how to incorporate the coordinates or this value from your drawing file, some kind of complex file which you have, you want to import that grids or the points to STAAD Pro. So that was the last class question which we ended in the last session. So I'll be carrying out that again in this day 2. I will show you a sample. So without AutoCAD, how you are going to do that as a possible way to make a structure, right? So that is the first part of the day. And second, proceeding to the day, we are going to start with a load calculations today. So for day 2, we are going to discuss on 3 major topics. So first is on, as I said, from AutoCAD and from STAAD Pro, how you are going to share the file or how you want to create the documents over there. And second topic which we are going to quickly see is on a static load. Today we are going to discuss on the static load conditions. So static load deals with your dead loads and live load, how you want to consider your dead loads and live load for a building. And second, third, and we are going to see some sample model. So I got some few feedback from students that you need to go with a live model. Yes, I agree to that. I'll be going today with the live models, and I'll be explaining you how the loads are carried out and how it should be discussed or how you want to apply in the real case of exercise, right? So that is a third topic. So to start with AutoCAD versus STAAD Pro, so you want to share some file from AutoCAD to STAAD Pro. So how it is possible? So you might be seeing a number of links or some videos they used to do through DXF file. So if you generate an AutoCAD file and save it as DXF file, and you can open in the STAAD Pro and you get your models generated over there, right? So few might be aware about this. I agree to that. But my question is, now I don't have AutoCAD. I don't have a AutoCAD. Then how I want to generate the model in STAAD Pro? So that is my question, right? So I'll be explaining you that soon. Then we need to know about a sample exercise, how we are going to do it. So here the present screen shows you a sample model of centerline method where the distance are measured through center to center coordinates of a building model. So imagine that's a simple building, 3-room set with a washroom closet is attached over here. So let's say this as a centerline method. So the distance are measured exactly. So this centerline method, the centerline axis, that's going to convert into STAAD Pro. So I need this file in STAAD Pro. So I don't want the wall offset. So as you see in the next picture, where you see the wall offsets, which is prepared in AutoCAD. So this is a model which I'm going to just going to show you a small sample, and I'll show one complex part. So how you're going to generate the complex diagram, right? So this is a base level. So this is a basic part, and then I'll go for complex structure. And then today, so you can see this model. So where you can see this offset wall offsets are there. So the wall offset is done clearly here. So it's 230 mm I have taken here. And you can see some columns are placed over there in the corners. And these are the inner dimensions. So these are inner dimensions or a drawing. So it is shown on the screen. And similarly, we need to do this part. Then later on what I did, so I created a file for that centerline option. So we can use the line options. So please avoid using polyline. So there is an option in AutoCAD you might be aware about polyline options. So try to avoid a polyline option. Rather than that, you can create a layer. So create a layer and make a wall name or a line, solid lines, and then you want to draw the structure. And one more note which you want to understand is do not make a line together. So suppose from here to here, I am drawing a single line. So starting to end, from start to end. So as a single line. So don't do that. So what happens in STAADPro, it will take from here to here. So it will not consider this in between nodes. So try to avoid doing that continuation line. So better than that, you can draw one by one. So one line and then second line and third line, and you can make a drawing completed. So this is one DXF file. So this is a format of DXF file. So from AutoCAD, we are bringing that files. So what is XF? So exchange of file. So X stands for exchange. So diagram drawing file. So this is your drawing file. XF is exchange of file. So from one software, you're changing a file. So that is called exchange of file. So the syntax here we use is .dxf, right? So then we need to know about the coordinates. Last class we are discussing about this coordinates, how you want to understand STAAD editor. So I was discussing about STAAD editor. So STAAD editor, mainly we need the coordinates. As I said, the most important points is your coordinates. So if you are aware about X, Y, Z coordinates, directly we can incorporate in the STAAD editor as well. So here is one sample where the red color icon shows all your nodes, and respective the axis is shown here. So what is the axis and its distance are shown in this part. And you need to complete till 12 nodes. So the so on same way we need to complete this part in STAAD editor also. And quickly we can see this member. So what I said, we need a member between two nodes. So you can see the members I have highlighted with the yellow color. So how many members are there in this building? So easily we can see 13 members are there in the ground floor. So this is a plan showing you 13 members at ground levels. So again, I have given a note for beginner, those who are doing in a beginner level. So from the beginning, if you have a practice, how to draw the beam. So there is a question, how to draw the beam in STAADPro. So some students, you have already worked in STAADPro, they go in random manner. So you go in a random manner, you draw the beams, one beam here, and suddenly you go here, again third beams you will be drawing, again fourth beam you will be drawing. So in a random manner, you start doing the drawing. So when you go to industry, please avoid that. So we should not do that in a random manners. So why we should not do in a random manner? What is the issue? So what is the problem in that? The software is going to analyze the beams. So what is wrong in that? Yes, the software will analyze whatever you draw or whatever you project on the screen. The issue is when you go for numbering. So when you prepare a detailed report or submission document to the client or for the contractor, so then there is a problem for you. So they may have the number of random numbers. The program shows you random numbers. So one number will be here, one number will be here. So it will not look a uniform pattern. So for that, I'm giving you tips for you. So start drawing your beams, a preferable manner, that is horizontal direction first. So you can complete either from the bottom or from the top corner. So draw in a horizontal manner. So first beam, second beam, third and fourth and 5, 6 like this. So proceed in a proper manner, that is horizontal and vertical manner. That will be help you to understand how you want to start drawing your drawing files. Right, clear? So same way, then proceed to the vertical members. If you see here, so 8 starts from here. So 8, 9, 10, 11, 12 and 13. So complete my vertical plans. So when you project your report, and it is easy to identify where is my beam numbers are coming. So that is the main reason I give importance for here, how we need to give a numbering properly. Right, and proceeding further, then we need to know about the load calculations, how you want to do this load calculation for this building. Right, so let's start with that. So here is a part for a small explanation where you know about it. So in AutoCAD, you have an option called save, and then you have other formats. Then you can click on DXF, and you can go for DXF file and put a proper file name, and you can save that. And then you can open your STAADPro file quickly, and you can see import. So from import, you can select that file name, and you can open it and keep sure that you have Y up, because we are working in Y coordinates. So this will be a height. So this is representing your height. So the plan should be selected in such manner. And make sure you are keeping there in a 3D manner, and you can project that. And so here are again certain tips. So please close the AutoCAD before you import. That gives you a flash of file exchanging. So there will be a warning or error message showing you certain things is active. So file is getting open actively. So at that time you cannot share a file. So you need to close your AutoCAD and then you can share your file to STAADPro. And second thing is maintain the units. Both drawings you need to maintain the same units. So in AutoCAD you are drawing in feet and here you are converting into meter. So sometimes there is a mismatch of units also. So please avoid that mistakes. You will get a proper diagram over here. Right. So the answer for my question is how you want to convert that file. So certain case the curved beams will not be reflecting on your STAADPro. So in STAADPro it's a big challenge for us to draw the curved members. So for curved members we need to calculate the radius. So what is the distance between these two nodes, and then I can draw the curves. Wherever I need a curved beams I can draw it. So for drawing this curve I need to know about the axis path. So which axis it is coming with, so quadrant. So I need to know about the quadrant, which quadrant I am going to draw. So this will help you how which angle I'm drawing the line and which quadrant this curve is coming. So according to that we can project your curves. Right. So further that what we have is load calculation. So before coming to the load calculation, I like to share my screen now. Just a minute. So because I need to show the answer for the last class question. So what I asked for you. So without AutoCAD file, how I'm going to use it. Right. So let me show you that right now. Okay, I hope my screen is visible right now. STAADPro window is visible to you all. Right, clear. So now I want to make some model here. So what I'm going to do is, so which I'm going to project over here. So what I'm going to do is your part, how without AutoCAD. So this is an AutoCAD file. I have some files over here. So I'm not going to use these files over there. So what I'm going to do is blindly I'm going to do something over here. You can watch my observation very clearly. So pay attention right now. So I'm clicking on new window. I'm clicking some example day 2. Already have file name. So I'm giving you sample ABC file. Right. So what I'm going to do is I'm keeping this as it is. So I have something in my Excel. So I have something over here. So the base coordinates I have. So what I'm going to do this base coordinates. So this is the coordinates I have for my plan. So I'm going to take this without help of AutoCAD. So that is my question was last class. So X, Y, Z. So base ground floor axis I have. Either you can take from survey. So you have some survey report. You can generate from there the coordinates you get for the ground plan. So I get this ground plan, whatever is obtained from my survey. I copy this file, and then here is a trick for you. Click on the node. Just click it on the node and just paste it. So once you get paste, it will ask you what is column 1. So it is not coinciding with my Excel sheet. So I should say that node 1, that is, I'm going to change that is X. So column 1 is your node. So that is node, and this is X2, and column 3, this is Y. Sorry, just a minute. Yeah, X, then this is Y, and this is Z. Right. So I keep this axis as it is, X, Y, Z. Click OK. Sorry, I didn't paste it. X, Y, and Z. So I got my grids over there. Right. So what I'm going to do that. Then I can use my add cursor. Then I can create my beams over here. So suppose I have a multiple story building here. So I have all the data of my floors over here. You can see this part. So this is a full building axis coordinates. So even that also I can do the same manner. I can copy around, all the coordinates I can copy quickly. So whatever is fully selected, and you can minimize and again paste. So every time you need to do this changing, X, and this is Y, and this is Z. Click OK. So you get all your coordinates to be pasted over here. So you can bring your structure like this also. So I'll show you sample example here as I already completed this model. So this is the coordinates. You can see that Excel sheet coordinates is here. So when you see that coordinates without any AutoCAD tools, I bring my structures over here. And then I complete my models in STAADPro. So I don't want help of AutoCAD over here, right? So if you are using AutoCAD, as I said, so let us do it in AutoCAD also. So here is one centerline part which I have made for the structure, right? So I want to use this diagram in STAADPro. So what I'm going to do, I just close my AutoCAD, then I go back, I'll create a new file again. So let's say test file 03 S, go ahead and then go for import, click on 3D-DXF file. Where is my center line? So I can select my file name and click OK, Y up, and then click OK. So now you can see my plan is over here, but this is the hidden features in my CAD file. Sorry, an AutoCAD files, which is hidden there. My layers are off here. So this is not necessary for me. So I can delete that. Now I can go for working on this model. So these are the ways we can bring the files and we can use for your exchange of files in various method, Excel or an AutoCAD. Right. Coming back to the class today's topic. So moving back to the topics today. So with the load calculations. So how to do the load calculation for a building? So we are aware about that. Normally a building has a roof slabs and your brick walls, and then you have floor slabs and plinth beams, etc. Now let us talk about a small sketch over here. So I'm going to take this small room. So I'm considering only this room right now. So which is this part. So I'm going to focus on this particular dimension. That is, I already showed you here in this sketch. So 5.75 and this length is 4.25. So I'm just going to take this shaded portion only. So how we need to apply the loads. So the rest is same procedure. Right. So let us take this room only 5.75 and 4.25. So I show here with this load calculations. So what is that load calculation? How you want to do it? So what we know basically that 4.25 and 5.75. So 5.75 is this side and another is 4.25. So this is a center line. Okay, center to center distance. Now this side there is a door and this side is a window. Another window is there. And imagine that this part is closed. I am considering this also as closed right now. So just focusing only on one room right now. So how to calculate these values of loads? So how I'm getting 1.1 or some values which you see here, how we need to do it. So we know that floor height is 3 meters. We know that the floor height is 3 meters. So for this 3 meters, we need to calculate the brick wall load. So what are the brick wall load it is going to transfer? It is going to transfer to your plinth beam, which is at the bottom. And whatever the slab you are going to rest on the top portion, that is going to rest on the roof beam, which is on the top level. If you see in your house, you can see the small section in your houses where the brick beams are there, roof beams are there. So what we are going to do, we are going to do calculation with height and this room beam depth. So how much depth we need to deduct it, right? And similarly for 4.2 side, on other side, the walls on other two sides, 4.25. So how much load it is going to transfer? So there is no opening provided. There is no openings are provided. So it is completely packed with the brick walls. It's completely packed with brick walls. So imagining that it's completely packed with the brick walls. So I'm going to get 13.1 kilonewton per meter. So the people already have calculated your dead loads. It's right. You have already calculated your dead loads or in whatever the method or in the textbook concept, whatever learned. Okay, right. So now how you want to do that in a perfect manner. So how you want to do it in the industrial standards. How, because different consultancy, we have different kind of correction factors. We can say that correction factors. So we adopt that correction factors from one consultancy to another consultancies. So the value is not going to be quite far away. So suppose I'm considering in a consultancy called A, my answer is 13.1. Suppose some other person is working in a consultancy B. Okay, so he is going to consider a slight modification in the beam depth. So suppose he's blindly taking a 300 mm as maximum, or 450 mm maximum, or 500 mm maximum. The value is going to quite close to within the range of like 12 to 15, we can say the range, which is not going to much more it. So we need to make an average value. So what is between this part? So that average value we are going to consider as a safe design. Right, because we are going to verify this in the software also, how much load it is coming, we are going to verify in software also. So that's what we are saying, that from different consultancy, we have slight correction factors, but concepts are same. Almost the concept, every calculations are same. But whatever the adoption of corrections by their own usage, that might be a light changing in their calculation part. So let's see that quickly here. So how we want to do this calculation quickly on this room. So you can see that two colors are there. One is a dark blue color that is shown as 13.1. Another one is a red color that is 11.1 kilonewton per meter. And I'm taking this floor slab thickness 125, and this is a ground level. And same manner what I'm going to do is for roof level. So for roof level, if you see in the section, as you see in the previous figure, so what is in the section? So this is a brick wall. On the top of your house, you might be seeing a parapet wall. So parapet wall generally we consider as 1 meter. Some kind of handrail portions or small brick covering portions will be provided all over 4 sides. And one side, if you have a ladder, suppose you have a ladder or some kind of staircase. So ladder and staircase you are going to provide. Some openings you need to provide. So what happened? The staircase will going to come over here. So there will be a small opening provided, but it is not going to have some additional effect. But what is going to have effect over here? The effect is the point load, where the staircase is going to rest. So at current case, I'm not considering any staircase or any ladder in my model. So in my model, I'm not considering any ladder or a staircase over here. So I've just projected a parapet wall all over 4 sides. But make sure if you are using any staircase or any kind of additional ladder, steel ladders you are going to project on your building. So what is the weight of this structure which is going to be get connected to the building? So what happened? That portion will project it as a point load. So that will be projected as a point load. So this is a ladder load, so which is going to rest on this part. So extra load will be taken on this particular beams. Right. I hope that is clear. Right. So right now we are not having any ladder or a staircase over here in this building, just a simple room we are considering. So parapet wall we are going to get 5.1. So I'll explain you all this calculation right now. So the calculation how it goes is from file. So I'll show you this part. First I'll show you the calculation. Yes. Here is the calculation. So what you see on the calculation is on your brick wall loads, how you are going to do it. So how you want to calculate your brick wall loads. So in some case, how you want to do that. So here is a problem I kind of spot. Excuse me. Yes, thank you. Right. So how you want to calculate this load, non-load bearing walls. So these all are comes under the non-load bearing walls. So load bearing walls are kind of shear wall or retaining wall or some kind of basement walls. So that's all comes in a load bearing walls. Please participants, I request you to mute getting noise at background. Okay, thank you. Rahman, excuse me. Yeah, thank you. Right. So going back, so the brick wall load, what you're going to do is how you want to take the load calculation quickly. So wall without openings. So let us take it as W1. So I have given the consideration what we are going to consider for this model. So I'm taking the wall thickness as 230 mm, inner plastering 12 mm, 15 mm for outer plastering, and unit weight of cement mortar, that is 20 kilonewton per meter square cube. And your beam depth, what we're going to consider as maximum size as 450 mm. So I'm considering that as you saw in the section where I showed the brick walls, the beam depth on the roof beam depth. So I'm considering that roof beam depth as 450 mm. And floor height 3 meter. So it's easy to understand this calculation, how you calculate your brick wall load on this particular beams. So you are taking the wall thickness 230 mm and converting it to meter over here, so 0.230, and plastering 12 mm, outer plastering 15, and unit weight of your cement mortar 20. And what is this? This is your floor height 3 meter minus your beam depth, So as I showed in your previous figure, you can quickly see that figure. So over here, so this is your floor height, and then you're deducting this portion. So that is deducted, and this wall will be acting on this particular beam, right? Fine. Come back. So you can see that over here. So once you calculate, you get 13.11 kilonewton per meter as a UDL load. Now it is understand to that the brick wall loads act as a UDL load. So the brick wall, whichever you are going to keep your bricks on this particular beam, wherever the beams are going to come. So this act as a UDL. So whenever in the interview they ask you what is the unit weight of a brick wall load, so don't get a blank. Okay, it's a UDL load. So units is kilonewton per meter. Right. Similar way for openings, wherever the door or windows are coming. So what we are going to do is we are going to deduct 15% of the weight from the previous one. So 15% is a thumb rule. So we are taking a thumb rule of 15% and we are deducting from the previous load. So what is the previous load? That is 13.11. So deduct that 100 minus 15, so 85. So 0.85 into 13.11, you get 11.14 kilonewton per meter. Right. So this is clear to you. Next part, which is on the slab wall. So for slabs, how we are going to do? So for slabs, we have floor slabs and we have roof slabs. So for floor slabs, the assumptions is taken, thickness is 125, and slab thickness for roof slab thickness also is same. I am taking 125. Now, what is the small difference with that? We have a unit weight of RCC, that is 25 kilonewton per meter cube. So I'm going to take the thickness, multiply with my RCC, that is unit weight, and this is your floor finish. Together, this part is called as floor finish. We generally call it as floor finish. So a certain consultancy, they take this as directly 1 kilonewton per meter square, or some may take 1.2, 1.1, 1.25, 1.5. So in detailed calculation, if you want to know in a very perfect manner, suppose some client is using a tiles or marbles or flooring tiles, something thickness is heavy. So according to that, we can deduct the size over here. What is the size you are going to cover in? So this is a size we are generally taking 12 mm and 75 mm as a floor finishing thickness and multiplying with the cement mortar. And similarly for the roof slab, when you come for the roof slab, what we are going to do is we are having a one particular case, that is your DPC. So when you go for DPC, so for protection from the rainwater entering inside the slabs, so we give double thickness. So we are taking 150 mm thickness over here. So rest we get the same, that is 6.36 kilonewton per meter square. Now it's very clearly know that kilonewton per meter square is a floor area load. So it is comes in a floor area load. So it is covering the area. So that is in meter square. So the loads is kilonewton per meter square. So in the interview again, someone asked how you want to calculate the floor load. So please don't say this alone. So if you are telling this alone in the interview, you are calculating only with respect to the thickness. So add, if you are given floor thickness in the question, so you need to take the floor thickness addition to your floor finish values also. Right. So up to here, I'm going to stop it, and then I'm going just sharing my STAADPro models. So right. So here is the part. I'm just showing you files, which is already done. Okay, so here is my model. So what I did, so I created that 4.25, and this is your size. This is 5.75, and this is 4.25. So what I did, so how you need to start this model. So first of all, you open your file. You can go to the geometry. As I said, you can bring your coordinates directly over here, or you can use this grid. You can use this grid method and you can project there. Now, what we want to do is, so I have not changed my axis. You can convert this axis as XZ. So you can bring your model and XZ values. So why X and Z is important? So when you draw a residential building or any plan, keep that in X and Z value. So that shows you a clear picture of the building. So what is the height, what is the axis or width. So now to start with this model, so quickly I'm going to start a very fast rate in this new model. So I'm just going to repeat this structure again. So you can see very clearly the loads which we calculated here is reflecting on the screen. So self-weight of the structure is available, and 13.1, the load which I showed in the picture, it is available by blue color, and again you can see 11.1. Now something is missing in my model. I'll tell you what is missing in my model, and this is the floor load. So you can see this floor load. Now when you see in the ground floor, this axis, the most important part. So number of students do mistake here. So since the model is very simple model here, it's a one room set, you're not using any range over here. So you're using X as 0, Y as 0, Z as 0. So no changes in this part. But make sure when you have some kind of different sizes and thickness of building slabs, I request you to understand this X range and Z range. For example, the picture which I showed earlier, a full complete model. So there are different types of X value, there are different types of Z value. So you need to add that values over here. Which slab you are going to select, that range you need to put it there. Then only the loads will be reflecting on the screen. If you're not using this effectively, your model is wrong. So totally your model is no use at all. So right, so here at the present case, we have only one simple floor slab. So we are keeping as 0, 0, 0 here. But when you look on my live load, that is next part, the roof live. So you can see on roof live. So 1 kilometer I have taken. The range is 3 meters. So height is now 0. So this is 0 and this is 3. Now what I did, I made a foundation 1.5 meter down. Now another thing which I said, a parapet wall, which is missing on this model. So I'm going to add that parapet also over here. So let me do from the new file. I'll show you the sample demo. So how to do it. So day-2 file. Right. So I'm giving R for repeat. So just we can start a new file. So I'm starting a new file. Those who want to start from the beginning, you can observe what I'm doing. So you can later on see the recorded section also what we are doing in that part. Right. So let's observe very quickly what we are going to do. So this is what the last class we are discussed till the Outlook interface, how you did it. So click on the edit. The very first step I do is XZ. So I change from XY to XZ. And then you need to adjust these grids. If you want to adjust the grids for a decimal value, you can do that 0.55 also. But what I'm going to do, I'll just keep it as 1 meter only. Click OK only. And then the most easiest comfortable for me, as per my convenient way, I will always prefer this part. So why I prefer this part is, so we will not do mistakes. When you have a drawing in your hand, you are looking at the drawings and you are seeing the coordinates and you are easily projecting that coordinates on the screen. So I see that the first coordinate is 0. So I get my grid point on the screen. The second grid point, which is I said for the first room, it's 5.75. So I get my 5.75 grid on my screen over here, right? So what is left? The next part. So if you want to make for another axis, so that is 0 and 4.25. So I get another node as on 4.25. Then second, again, this should become for 4.75. So I'll use 5.75 and then go for 4.25. So I get my nodes here. So once I get my grids, I just close it. I click on add beam. Last class I taught you this, add beam. Click on add beam and proceed as I said the rule. Horizontals first and then verticals. Right. So wherever you are starting, that becomes a start point. This becomes an end point. Right. So always remember where your cursor is started and you're drawing a beam. So this will be a start point and this will be a end point. So I got my room structures. Another alternative way how I can do this model. So I'm just undoing it. So another way how I can do it. So I projected only 2 nodes, right? So I can just click on this one beam, use beam cursor, change the cursor to beam cursor. Now this is called a box selection. So when I use a box, a square box on my screen, so this is a box selection. Select this whole beams. There is an option called translation repeat. So click on that. So which direction you want to project that? You need to project in Z direction. How much meter you want to project? I need to project in 4.25 meter. How you want to connect the beams also. So I prefer links. Now click OK. So you get your models done here. So either of the way we can do this. So once you complete this model, now what I'm going to do, the second step is load calculation. So go to the load calculation. So click on general. So where is load is available? The load is available on general. So once you click on general, you can see load definitions. Click on that part, go to load case. Right. Now the thing is to observe here is, so you have 2 parts. One is load case. One is called load case. Second one is called load pattern. What pattern your load is. So that is different. So load case you have around dead load, live load, traffic, temperature, your gravity, or your pushover analysis, or rainwaters or dust. So these are all the load types. So these are all called load types. And what is load pattern? So when you select one particular case or a load type, dead load, and then you add, you can give a name called dead load. Now click on that. Now once you've done that, you can see the name over here, dead load. For this case, what is the pattern? What type of pattern load is there? UDL, UVL, point load, joint loads, or coordinates loads, or some kind of a moment. So that adds something different. So once you click again on add button by selecting this dead load, add again. Now you can see the patterns. These are called the load patterns. What load patterns you need? Suppose I need a load pattern of plate loads or hydrostatic force. So I'm dealing with a dam structure or retaining walls or water tank. So I need to go for a plate loads. So I prefer a hydrostatic loads. Or I'm going to work on the floor levels, roof slabs. I'm going to give a pressure load here. Another one is the area load. Some kind of area pressures are there, uniform pressures are there. So that is there. Or member load, uniform load, concentrated force, or your varying moment you want to use. So this can be used over there. The most important thing is very first step is on self-weight. So whatever the structure you create, so that has a self-weight against the gravity. So that is always in Y direction until or unless you work in a dynamic part of loading. For static condition, we use Y. So we are using for static condition today. So it's -1 only. Right. The next observant thing is on member load. So what is your member load is available? So we know that 11.1, what you see on the screen. So that is your 2 values, what you saw on the board. So that is 11.11 and 13.1. So this is your UDL load. So which we need to add in the STAAD Pro. So I'm going to take this 13.11 and 11.14 kilonewton per meter in the STAADPro. So going there, so we are going to add that minus 13.11. So what is minus? It's against to gravity. Right. So there is no distance. Last class I showed some samples. So that is your distance, D1, D2 distance, how much it is moved from the origin point. So we don't have any origins here to move. The distance is not moved here. So it is 0, 0, 0. So it is uniform all over the size. So add that. Once you click, you see on the screen there 13.1. The next load is minus 11.14. Add that also. Done. Next, what is remaining? As I said, the parapet wall. So I'm going to add that parapet wall. So how to calculate this parapet wall? So parapet wall calculation is also similar. So for parapet wall, how we do is the same calculation what you calculated for brick wall. So same 0.230 plus 0.012 plus 0.015. Now multiply with 20 into your height of your parapet wall. So rather than 3 meter, the parapet wall height. So height is 1 meter. So into 1. Further that there is no beams or nothing is resting on the structure. So nothing should be minused over here. So we are taking 1. So if you work out on this calculation, you get 5.1 kilonewton per meter. So this is the answer for parapet wall. So I'm going to apply that 5.1 over there. So minus 5.1 over there. Right, done. So this is done. Now what is dead loads? So dead loads are all done. Now what is live load? So create load case. Sorry. Click on case. First create the case. Change this to live load value. So what is live load now? So we have 2 floors. One is floor slab, one is roof slabs. So again, for roof slabs and floor slabs, you need to know about the live loads. So you need to consider the live loads as per Indian Standard Code Book. That is 875 Part 2. So I hope you have this code book. If not, you can get it from online also, or even I will share the code book for the freshers or the beginners, those who don't have this code book, or those who are going to learn the STAADPro for the first time. So definitely this is very, very useful for you. So we are using for Indian Standard 875 Part 2, and there we are number of classification of buildings are there. Different types of buildings are there. Commercial building, hospital building, residential buildings, etc., education building. So all these are there. So for that we need to see which rooms for bedroom, kitchen, hall or office room, what is the live load is provided. For this current exercise, I'm going to take 2 kilonewton for floor slab per meter square and 1.0 kilonewton per meter square for the roof slabs. And then we are going to consider a simple dead load calculations, load combination, 1.5 times factor is multiplied with your dead loads and live loads. So taking that considerations, so what we are going to do, we are going to go here, add the live, go to floor load. Now the most important observation here. So there is a difference between your area load, floor load and plate load and also surface load. So everywhere you see the units is same, kilonewton per meter square. In plate load also you see kilonewton per meter square. In surface load also you can see, but here in surface load you need to see full pressure. So here also you can see kilonewton per meter square, or in area load, kilonewton per meter square, right? So I'm just going to give a task for you for the day. So you're going to observe what is the difference of this part, why we are going to go for floor load, plate load, area load, right? So hold on with this question, right? So I'm going to explain later on this part. So for this current exercise, we are going to take that on floor load. So we are going to give that floor load -2. I'm going to add that. And then roof live, that is should be replaced as -1. What is the height of the floor? It's 3 meter. So after 3 meter only my load is acting. So the minimum and the maximum value is 3. So I'm getting that on the screen. Right, so all done. So we can go for first the load 13.1. So select this where the walls don't have any things. So this is done. Select. Here are 4 options for you how to assign the loads. So one is selected beams, you can select that. And next for these two beams, select that. And now we are not going to touch this 5.1. The floor load is not shown here, but this is again showing error. Right, so how we want to do this correction? Now, after doing this model, just select a box selection. Select a box selection. I'm doing again box selection. Translation repeat. We have an option called translation repeat. You can see over here, or you can go to the geometry. You can get it over here also. Select translation repeat. Which direction the building wants to move? The building wants to move in Y direction. I want to move in Y direction. What is my floor height? My floor height is 3 meters. Link steps and click OK. Now you should not give, this is an important point. So there are certain flags for you. So what is this flags basically is asking the user what you need to do it or what you want to repeat it. So I want to repeat all the loads or geometry properties, etc. So I don't want any loads or geometry to be repeated. I need only the geometry to be repeat for 3 meters. So link step. So use geometry only. So the loads will not repeat there. Right. Now you can select this parapet wall quickly on all 4 sides. Assign to the selected beams. So you get your parapet walls on this top. Now you can check your roof live load -1. So it's available on the top. Now quickly you can see on this orientation, you can see this yellow color icons on the screen. So there are certain icons over there. So you can select one of the icon which shows your sectional view. So -Z, if you talk about -Z, it shows one sectional view. Now current cursor is beam cursor. I can select only the beams. I cannot select my nodes. So I need to change my cursor to node cursor. Select the nodes cursor. So don't select one by one. Using control button, don't select one by one. The shortcut trick is again box selection. See on my screen. Select like that. So your entire nodes will be selected. Whatever the model is, whatever the model shape is, your entire base nodes will be selected. So keep it in section view and use node cursor. Select a box selection. See on the screen very clearly, a box selection. So this will not select your beams. It will select only the nodes. Then click on your translation repeat. Y direction. This is my origin 0. And this is 3 meters. I'm just going to give it as -1.5. I'm going to go below the depth of the ground floor. So -1.5 I'm taking roughly for this model. Again, geometry only. Link step. Okay. So I got my structure there. Now click on support because we need to give the supports also, right? So for this complete model, let's just give a fixed support. So I'll come back to this part tomorrow class. Different types of supports we are going to discuss. Presently, I need to complete this model sample. So just I'm clicking on fixed. So you can click on create. You can see various types of model supports there. So at present, I'm taking a fixed support. Add that. So you can select again the same cursor like this. Assign. Now keep it in isometric view. That is 3D view. You see your model is ready. So this is the way we complete your models and all the loads are applied on structure. Right. Now what is left? We need to give some size, right? So we need to give some size to the beams and column. So we need to give some size, rough size to beams and columns. So you can take it as a beam size. So let us imagine that beam size 230 by 300 and column size, let us take 300. Sorry, 325. Right. So I'm going to take this as n values. So we're going to add this part. So going back again here. So here is option again in general. Click on general, you have properties. So last class I showed you what is the properties. Click on property, define the size. There is an option called define. So you need to define the size. So what size I said? First is your depth. So depth is 300. So it is in meter. So 230 mm for the beam. Add. For column, it is again 300 and depth is 325. Right. So I'm taking in meter. Close this. So I want to assign this part to all the beams. So how I can do this? So we can group. There is an option called grouping also we can do for grouping. So I'll come to that later on. So for simple selection, so you can use this select button, go beams parallel to X and beam parallel to Z. So we need only Z and X, right? So beams. So these are all called beams. So these are all called beams. Assigned to that. Now what is left? The column. Go to the columns, beams parallel to Y directions. Right, assigned to that. So I'm not assigning the plate. So on this model, I'm not assigning any plate here. So why I'm not using the plate, the answer for the question which I showed on the screen is the plate I'm not taking here. At present, I'm not taking the plate. I'm using the floor load. I'm using floor load. The floor load concept is distribute. It will distribute the loads to beam. So I don't want any plate or any plate thickness to be run on this model. So whatever the floor load I give, the floor load will be distribute the load values to the beams. So for this beam, the loads will be distributed. So as you saw in the yield line diagram, last class also student asked what is that yield line diagram. So it looks like that. So now the loads is distributed to your beams when you click on floor load. So the stiffness is governed by the beams, not by the slabs. So make my word clear. The stiffness is not governed by the slabs. It is governed by your beams. But yes, when I change the option as a plate load, then the stiffness matters for me. So the slab stiffness is very important for me. The slab will take the load and it will show the deflections, everything. So this case is the difference what you saw in this plate load and floor load. Now what is area load? As we saw area load also. So area load is a particular portion where the load should be distributed, some kind of stresses. So there we go for area load. And surface load come for your meshing concept, that is for shear wall designs, we go for surface load, right? So coming back to the model, so I'm not adding any plate here. Now I want to check anything is missing over here. So you can click on missing data. So you can click check that anything is missing here. So you can select on missing attributes. So no missing data is found. So you can just click on analysis. Let me check the loads. Everything is done. Sulfate is assigned. Okay, now sulfate is missing. So I'll click on assign to view for because building is ready. Assign to that. Now you run the model. You get your results. Sorry, something I guess property is missed. Yes. Analysis command is missed. Go to analyze static load condition. Click OK. So you get your answers. What are the values you want to be done? You get your results. So what is the load applied? What is the reaction value? Or what is my load at this particular point? So you want to see this, that. So you can see the reactions and load values. So this up to here it's completed. And the last step which you want to add a load combination, just go to load case, click on add, click on define combination. You can just type 1.5 dead load plus live load and type the value here, the multiplication factor 1.5, add this both. So you can see the factor there. Click yes. So you can check that also. So just close this file and then run the analysis. So that completes your dead load and live loads. You can go for post-processing. Under post-processing, you can see the values, right? So that's for the day. So you can see all your values. What are the shear force diagram, a bending moment diagram, or beam stresses. What is the beam stresses are coming? You can check through stress profile values also. So you can see the stress values for the beam. But we are not done the design. So this is only analysis report, right? So just we are done with only the analysis and we are getting all the reactions. What are the reactions to be done? So if I want to know what is the total load on this particular column, what is the summation of loads on this particular column, click here, click on reactions, FY. See only on FY. So we are not considering any FX on FZ. So see what is there in FY. So 1.5 times dead load plus live load, 195. So for this particular column, 195.46 kilonewton is the load value. So that will be carried for the column design. So where you can see for the column, so 195 kilonewton load is coming. What are the moments? We need to see for biaxial moments. We have studied that. So it's called biaxial moments. So mx and z values, not on my. So ignore fx and fz should not be considered. Fy should be taken care. And here my should not be considered. So this should be considered. So that completes your static load calculations. So that completes your static load calculations. Okay. Okay, Sahil. Okay, we will take care of your notes. So fine. Plinth beam in the model, yes, it's required. The ground level is your plinth beam. So always, whatever the software you use, the ground level where your access coordinate is 0, 0, 0, it is considered as a plinth beam. Okay, until or unless you have some basement structures. So if you have some basement building, then your building basement below that certain level beam considerations will be there. That is called basement beams. So that is a basement beams. Until or unless your ground level is maintained 0, then that is called plinth beams. Okay, fine. Fine. So let's go to the two basic questions as asked by circular slab, curved beams and slab load calculations. Okay, so the person who asked the question, so you can observe the case here. Suppose I want to draw some arc beam on this model. So click on your modeling, go to the modeling, click on geometry, add beams. There is an add beam and you have see curved beams. Click on that. Now I know what is this 4.25. So I know what is this distance. So radius means the same distance. What is 4.25? So once you click 4.25, the distance what you provided, this is my off radius. Click OK. So you can see that curve is coming here. Now the point is which coordinate, as I said, the coordinate, which coordinate your curve is made. So that you should take care. Now how to do that? So click again. Once you give 4.25, the gamma angle. So we call it as the coordinates as gamma angle. Suppose I say 270. Now you can see that it comes as a curve. So you can see that there. And you see here. So the coordinates, which coordinate you're making. So now this is 270. Now I want to draw the same part here on this shape. So same 4.275, sorry, 2.25. If I give 270 coordinates, the curve comes again that side. If I give minus 275, let's see opposite side. I need an opposite side. Minus 270. The coordinate is negative side. You get your negative sides. So like this, we need to generate a model. So as I showed your previous model, so where you saw your previous models, so you can see this part. So each one is done at the ground level. So we do it in the ground floor. So we completed the model in the ground floor. So we do it in the ground floor. So all these models will be drawn CAD and we give the properties for this. So for that only we have the groups. So we have group names. So curved beams or circular beams where it is coming. So we select that beams only. So we group this and we can go for the design. Now second question asked by the student, how to apply the loads for this. So for this we need to divide the section using a dummy beams. So we use some kind of dummy beams and we need to add the coordinates here. So then we need to do the meshings. So that is a little bit higher advanced level. So you need to generate the surface meshings. So first you need to create a surface meshing and you need to do the hatching for all this portion. So let me explain in your PPT. Just a minute. Any other question in meanwhile? So before we get close the sessions, you can drop the question quickly. Okay. So how we do that? So if you have a slabs, so this is a beam and this is a curved beam. So what you need to do, you can divide the segment with drawing the coordinates. Now you need to draw one more coordinates like this. And then wherever you can add 3 noded plate, suppose here it is a perfect triangle, you will get like this. So this is a perfect triangle, so 3 noded plate. So you can add 3 node plate over here. So that will do the meshing here. So this is also another triangle. So this will also get meshing. Now what about this portion? This is a curved member. So this is your curved members. So for this we need to add certain beams, small beams correspondingly until you get either a perfect square or you get a perfect triangle. So this is called meshing. So we need to create these coordinates for that. So until you get a perfect shape for this curved members, triangle or a square, and then you need to do the meshing, then you can apply the loads on this particular slabs. So it will take time consuming for making that models over here. So for making the calculations, how you want to divide the segments, it's simple. Just you need to go for segments of the circle. So suppose you have a circle. Divide the segments, different segments. And then you need to do perfectly for this curve, you will not get again. So this might be go like this until you get a proper shape. So each one will be looking as a small segment of rectangle and triangle. So that is a question. Okay. So that is will be taken by meshing part. Any other questions? How do you want to provide a members? Okay, that is economical questions. Some combination load is done. Any other questions you want to discuss? Please let me know. Can we import members also with node from Excel file? Yes, we can do members from Excel file. Whatever the Excel sheet you prepare, say suppose you have a survey, if you are going for survey, you are taken some grids, survey grids, and your contractor is giving you the survey grids, but you didn't get your architectural plan or any inputs. So with that survey grids, if you are able to create a plan or if you are able to create a developed grid models, you can do it. Another thing is your CAD file where you create a grid columns or Rivet models. Even for Rivet models, you have Rivet grids. So you can import that Rivet grids also. But problem is in the advanced level of STAADPro, we have one more part in Connect Edition. Not in this model. In Connect Edition, we can export the grids directly from one software to another software. Okay, so that will be helpful for you to do much easier than this part. Okay, complex diagram done. So in last session, you can teach INS water tank. INS water tank, it will take time consumption, so not for all people, because all are at the beginner level. INS tank is somewhat MTech level concept. But yes, I can show some sample just in the meantime. So INS tank, I think. Right, so coming back. So let me share you some case, just last minute. Yes, so if any questions you can ask now.
Sir, I left the previous class. Can I see in recording?
Just a minute. I'm just coming back to you once.
Sir, how to put the circular beam, sir?
Yes, please.
Sir, how to put circular beam, sir?
Circular beam. Okay, your question is on circular beam. Okay, so please submit your feedbacks. I showed you screen, there is a QR code as well as the link is shared to you. So kindly share your feedbacks. Right. So how to add circular beams? That is your question, right? So see, circular beams, you need to calculate first the radius value, how you want to do the radius value. So I'm sharing the file also, just a minute. Okay, fine. Just let me share the screen, just a minute. Okay, in meanwhile, you can drop the questions. After that, we'll take the question sessions. Feedback link is given in you in the chat box. So you can give your feedbacks over there.
Sir, I missed the previous class. How can I see that?
Okay, so yeah, we will share your recorded copy. Okay, you can share that recorded copy and you will be getting the link over there in a school web page, the Facebook page. So you can get from there also. Okay, just a minute. Okay, so you can post your questions in the chat box. We will have a discussion of questions after this meeting, right? So you can keep posting, and those who have the questions, you can interact with me right now. I'm just stopping the presentation now and we'll go for discussion questions. And thank you for the participants who attend for day 2. And tomorrow class, we are going to discuss on the design, certain cases of a beam grouping. We are going to discuss on beam grouping, supports, and then we are going to see the design inputs, how we need to go for a step-by-step design inputs. So these 3 topics will be taken care by tomorrow. Okay, so thank you for all the participants. Now we will go for discussion round. Thank you. I'm stopping the recording right now. Thank you. Okay, yes. Please let me know one by one. The questions are first question. Okay, first question from Yuvraj. Sir, please show assign floor loads to floor having circular beams. Okay, fine. Then second question about repeat load in load cases. Okay. To support 1.5 meter depth. Can you provide a ground level that is y equal to 0? Yes, we can provide, but make sure that y is your ground level, that is your foundation depth. So we are always taking foundation depth below that. How we do know provide the members are economical or not. So that we are going to see in the design. So once you go for design, you need to see from optimization results. So what is the size? We are going to see that failure patterns where the deflections are within the limitation. Then we can go for optimized size. Yes, explain about why we can assign combination load. See, combination load is basically required because we can't depend only on the dead load of the structure or live load of the structures. For example, seismic or some kind of cyclones or some kind of wind which is going to act on the building. So we need to know what is the building behavior. So we need to go for various combination. So one such basic combination is your wind load, dead load plus live load into your 1.5. That is a very important combination. Okay, let me go back to the models. Let me share my screen. Okay, any other questions? Support will be explained in next class. Yes, supports will be explained in next class. So what are the different types of supports and what are the applications that will be discussed, and your properties, we will be discussing about the properties also. Okay, so any questions? Okay, sorry, repeat load in load case. So repeat load, we can use that for some kind of a transportation, some kind of a load on slabs wall. We can go for repeat load combinations. So for making repeat load, we need to create some kind of vehicle loads generations. Then you go for load case, and then you need to prepare some set data. What are the load you want to repeat? Some kind of cyclic load. So you want to do that cyclic load combination. You create that in an Excel sheet. Again, I can take a help of Excel sheet. You create that load set which you want to repeat it. For example, a vehicle moving on a slab. For example, I'm taking a slab analysis. So a vehicle of certain values that should be repeated. So we can create that as a vehicle definition, and then we can give that as repeated loads or cyclic loads. We can give that part. So for that, we need to have some data for it. Presently for repeat load, I don't have any data. So we need to create a data for it. If not, let me bring tomorrow at the end of class, I'll help you out vehicle loads. So for vehicle loads, we can go for it. Yes, next, any other questions? Yeah, it is related for seismic also, we can go for repeated loads. That is our time history analysis. Time history analysis we can go, and seismic responses also we can go. We can use that. Any other questions? Fine. Okay, so we'll close the session now. So thank you for all the participants.